In this demo, we're going to talk about conservation of angular momentum. So I have these dumbbells I'm going to use to change my moment of inertia. So moment of inertia quantifies how distributed mass is relative to the axis of rotation. So I'm going to rotate on this chair, give myself a little kick, and I can get some angular velocity. When I have angular velocity, I also have angular momentum. Angular momentum is related to moment of inertia by multiplying moments of inertia by the angular velocity. So I times omega will give you angular momentum. So I can change my angular momentum by spreading my arms out or bringing them in. So let's start with some velocity, angular velocity. As you can see, I'm rotating. I have some angular momentum. And when I spread my hands out like this, you'll notice that I'm slowing down quite a bit. That's because I have increased my moment of inertia by bringing that mass out. So if I bring it back closer, I speed up again because now I've reduced my moment of inertia. So the amount of angular momentum stays the same. What's changing is the moment of inertia and the velocity. If I increase the moment of inertia, the velocity, angular velocity, will go down. And if I bring down the moment of inertia, decrease it, then the angular velocity goes back up. So that's conservation of angular momentum.